Let's have a look at more complicated examples of indefinite integrals. Here we don't have direct formulas that allow us to do these indefinite integrals, but what we can do is appeal to some of the rules that we have about how to manipulate indefinite integrals and split these up into situations where we can directly use our formulas. So let's start with question A, which asks us to do the indefinite integral of 1 over x cubed plus e to the power of 2x dx. And the first thing that I'm going to do is kind of look at this term, this first term, 1 over x cubed. Don't really have any formulas really for something that looks like this, but what I can realize is that this is nothing more than just x to the power of negative 3. So I can rewrite it x to the power of negative 3, because I do have a formula for something that looks like that. And then e to the power of 2x dx. So I've done nothing in this step except for rewrite 1 over x to the power of 3. Now I do have rules that tell me about how to manipulate two functions added together when you do an indefinite integral, and what the rule says is that I can actually separate these into their own independent indefinite integrals. So I can just split them up like this. So I have the indefinite integral of x to the power of negative 3, and then I have the indefinite integral of e to the 2x dx. And now I do have formulas for these things. This becomes negative 1/2 x to the power of negative 2 plus, say, a constant c1. And this becomes, using our formula, 1/2 e to the 2x plus another constant c2. Now I have some arbitrary constant, no idea, just some number, doesn't matter. And I have some number, doesn't matter, over here. If I have some number that doesn't matter and I add it to another number that doesn't matter, what I end up with is just some number that doesn't matter. So I'm just going to collect these two constants into one master constant. I'm just going to simplify this as 1/2 x to the negative 2 plus 1/2 e to the 2x. This master constant plus this master constant just becomes some giant constant c. Okay, so let's do something similar with question B. Question B is asking us to do the integration of 9 over x dx. Now I have a rule that tells me that if I have a number, a constant, that is multiplying a function, such as the fact that 9 is multiplying the function 1 over x, I can just actually remove that constant outside of the integration, so I don't really have to worry about it. And then I just multiply it at the end to the result. So I have a formula for what the indefinite integral of 1 over x is, and that is 9 times the indefinite integral of 1 over x is the logarithm of the absolute value of x plus some constant, I'll call it c1, and then when I multiply the 9 back through, I get 9, the logarithm of absolute value of x, and then 9 times some arbitrary constant is just some other arbitrary constant, which I'll just call capital C. Okay, so the last example, so C, asks us to find the indefinite integral of 12x to the power of 5 minus 3 e to the 7x plus 2 over x. So again, we don't really have a formula for something that looks this complicated, but what we can realize is we can use our indefinite integral rules to kind of separate these into simpler indefinite integrals. So the first thing I'm going to do is exactly what I did above. I'm going to separate these into 3 independent indefinite integrals. So 12x to the power of 5 dx plus the indefinite integral of negative 3 e to the 7x dx plus the indefinite integral of 2 over x dx. Okay, so now that I have 3 independent indefinite integrals, I can keep making things even simpler on myself. In the first one, I see that there's a constant multiplying the function, so I can actually take the constant right out, 12 x to the power of 5 dx. This constant is negative 3. I can pull that out, so that becomes negative 3 e to the 7x dx. And then I have a constant of 2 here, and I can pull the constant out. This becomes plus 2 and the integral of 1 over x dx. Now I'm in a position where I have formulas for each of these indefinite integrals, so I'm going to use them now. This becomes 12 1 over 6 x to the power of 6 plus a constant. I'll just call that constant c1. We write the constant here, or the thing sticking out front of the indefinite integral. If I use the formula for this indefinite integral, I get 1/7 e to the power of 7x plus another constant. I'll call it c2. And then I have plus 2, and then the indefinite integral of 1 over x is ln absolute value of x plus another constant I'll call c3. Now I can go and multiply these things, these constants that I had pulled out, I'll multiply them back in to simplify things. So 12 times 1/6 is just 2. So 2x to the power of 6. 12 times a constant, some arbitrary constant c1. I'm just going to call some other arbitrary constant d1. It doesn't really matter what I call it. I'm going to do the same thing here. So negative 3 over 7 e to the 7x. And then the negative 3 times c2, or 3 times c2, I'm just going to call, say, d2. So this becomes minus, say, the constant d2. And when I multiply this 2 in, I get 2 absolute ln of the absolute value of x. And then 2 times c3, I'm just going to call, say, d3. Now I have some arbitrary constant here, d1, minus an arbitrary constant here, d2, plus an arbitrary constant here, d3. I don't know what these are. It doesn't matter what they are. When you kind of put them all together, all you get is another arbitrary constant. So I'm just going to collect them all into one giant arbitrary constant, which I'll call c. So I'll clean this up to be 2x to the power of 6 minus 3/7 e to the 7x plus 2 ln the absolute value of x. And then all of these constants put all into one place. There's just one giant constant, c.